Welcome back, my friends. Today we are on lesson 14 on Zearn. The title of this lesson is For Good Measure. In order to do lesson 14, again, you're going to have to do all the lessons that precede it, that come before it. So make sure you're doing 1 through 13. Today we are on 14. Okay, let's read our objective together. Students will be able to solve word problems involving the addition of measurements in decimal form. So today what we're going to do is we're going to use our addition with decimal numbers, but we're going to look at these problems in the context of a word problem. So we're going to be able to identify the different pieces of our word problem and how to apply addition to them. As always, you guys just finished your dream box. Make sure that you're doing your fluency activities, your number gym, and your pair compare. We're going to dive right into our guided practice today. That is called the Z Squad. I have a feeling we're going to meet up with some friends who are going to help us with our word problems. Let's do it. All right, here we go.
Hi, I'm Deasia, and I'm in the Zearn Squad.
What's up, Deasia? We're excited to work with you today. All right, read the problem and imagine what is happening. So we want to visualize this problem, see if you can paint a picture. As I read it, I want you to follow along. A team of 3 friends ran a relay race. Camille ran the fastest, measuring 29 and 2/10 seconds. Marco was 1 and 89 hundredths seconds slower than Camille. Lena ran 9/10 seconds slower than Marco. What was the team's total time for the race? So let's start to visualize. It's a relay race. There's multiple people. Some are running faster, some are running slower. And let's go ahead and use our numbers here. Before we do, let's answer this question. What are Camille, Marco, and Lena doing? So what are they doing? Are they running a race or are they walking to school? So we can see it's a relay race, and they don't mention school in the problem, so that doesn't need to be in our answer here. We know that they're running a race. Nice job. Do they all run for the same amount of time? Well, what do we think? Do they? It looks like Camille runs the fastest. Marco is a little slower, and then Lena is a little slower than Marco. So it looks like no, they do not run the same amount of time. Who took the longest? Okay, so it tells us that Camille ran the fastest, Marco was a little slower, and then Lena was a little slower than Marco. So who ran the slowest? Lena, because she did run the slowest. Or Lena took the longest, I'm sorry. She took the longest to finish, which means that she ran the slowest. So the longer it takes you to finish a race, if I'm racing, I don't know, if I'm racing Brian, for example, Brian's really fast. He's going to crush me. So it takes me a longer amount of time to finish the race. It takes Brian a shorter amount of time to finish the race.
Camille, Marco, and Lena are running a relay race together. They are running at different speeds at different times. Camille ran the least amount of time, and slower runners will take more time. Lena is the slowest. She'll take the most amount of time.
Okay, let's order these runners from fastest to slowest. Let's put the fastest on top, and let's put the slowest on the bottom. So we just said that it tells us that Camille ran the fastest. So let's put them at the top. And we know Lena ran the slowest, so we'll put her at the bottom. So who was in the middle? Well, there's only one choice left. There you go, Marco. Boom. Nice work. Okay, if you don't have a piece of scrap paper or your notebook to write in, make sure you get that right now. I would pause the video and make sure you have something to do your computation on, to do these problems on. All right, let's list the initials from fastest to slowest, all right? And we're going to list them vertically just like this. So on your note paper, I want everybody to put a C. I want you to put an M. and I want you to put an L just like this and make sure they're lined up vertically. Okay? I'll be using theirs down here, but we want to make sure that they're lined up vertically. CML for our 3 friends in the problem. All right, we're going to answer these word problems in parts. I don't want you to look at the whole thing at once. We're going to break it down step by step. What was Camille's race time? So it tells us Camille ran the fastest, measuring how long? How long did it take her to run the race? I want you to plug that answer in and press enter. Let's see if you're correct. Well, it tells me that she ran 29.2 seconds. Okay, I entered it. It's correct. Nice job. How many more seconds did Marco run than Camille? So Marco took longer. So he ran more. It took him more time. How much more time? Well, Marco was 1.89 seconds slower. So I think it took him this much more time to run. So that's how many more seconds it took him to run than Camille. So let's click 1.89 seconds. Nice job. Okay, we're going to use a tape diagram here. So our job, draw a tape diagram to represent this problem. Start by drawing and labeling tapes to show Camille's and Marco's relay times. On your piece of scrap paper, next to your C, M, and L, we're going to draw our tape diagrams. So let's start by drawing Camille's. I'm going to start by drawing a rectangle just like this next to Camille's letter. I want everybody to do the exact same. And in the rectangle, I want you to tell me how many seconds it took Camille to finish the race. Well, it tells us right here. Let's underline that. 29.2 seconds, and let's write it in her tape. 29.2. I want you to do the exact same thing on your scrap paper. You can disregard this outline, this yellow outline here. Okay, we have Camille's tape drawn. Now let's draw Marco's. So the key to Marco's tape, he ran the exact same amount of time, but he took a little bit longer. So we're going to draw the same tape diagram. Try to make it the exact same. But he took a little bit longer, not that much. So I'm just going to put a little piece right here. Just a little piece. So we know he ran 29.2 seconds, but then he also ran a little bit more. What's that little piece worth? Yes, he ran 1.89 seconds more. Okay. All right, we're only going to do Camille's and Marco's for now. We'll save Lena's for a little bit later. I want you guys to have this down on your scrap paper before you move on. Pause the video if you need to continue writing it. If not, follow me.
I drew a tape diagram for each runner. Camille had the fastest time, so that means her tape diagram was the shortest. I labeled Camille's tape diagram 29.2 seconds. Then I drew Marco's tape diagram. I drew a tape diagram the same length as Camille's, and then I drew a little more to show that he ran more time. So the part I added was 1.89 seconds.
All right, y'all. So I really like what they did. Now, they didn't write 29.2 seconds because they're just assuming that this piece of Marco's tape diagram is equal 29.2. That's their assumption. So make sure that your tape diagram matches Deja's right here, and then let's move on. Okay, here we go. A beautifully drawn tape diagram. And let's read the next piece of our problem. Will Lena's tape diagram be longer or shorter than Marco's? So let's think about it. Lena took longer than Marco. She ran slower, right? So if she runs slower, will it take her longer to finish the race or will she finish it faster than Marco? Well, I think she took longer to finish the race because she was a little bit slower. Just like it took me longer to finish the race against Brian because he's super fast. Very nice job. How many more seconds did Lena run than Marco? How many more seconds did Lena run than Marco? Well, how much slower did she run? Let's look back at our problem. I'm going to underline it this time. Lena ran 9/10 of a second slower than Marco. So we know this is way too large, 9 seconds. This is less than 1 second. So we're going to pick this option here, 9/10 seconds. Nice work. Okay, so let's go ahead and to our tape diagram, our drawing so far, we're going to add one more tape for Lena. All right. Now we know Lena's is the same distance as Marco's, but she ran slower, so it took her just a little longer. Okay? So it's the same distance as Marco's, but she ran just a little bit slower. How much slower did she run? You guys, if you want to draw it a little bigger so you can write your numbers inside the tape, right, that's fine. I'm going to draw a little arrow here to write how much longer it took her. We can see it took her 9/10 of a second. So I'll write 0.9 out here. That's what that extra little piece here is worth on our tape diagram. And now we have Lena's drawing. Make sure you catch up. When you do, let's move forward.
And lastly, I drew Lena's. And at first I drew it the same length as Marco's. And then I made it a little longer.
Nice job, Deasia. All right, at this point, make sure you have a really nice, clean, and organized tape diagram, just like we have here on our slide. Once you do, let's move forward. Okay, what is the problem asking us to solve for? What is our problem asking us to solve for? Well, luckily, they separated our answer right here. Okay, so I'm going to underline this. And I'm going to read it nice and loud. What was the team's total time for the race? Remember that key word, total. What does total mean? What operation will help us find the total amount of something? Well, when you see total, it should always tip you off to add, all right? And if you're not adding, it's usually repeated addition or just addition. And we know repeated addition is the same as multiplication. Okay? All right, MULT for that, multiplication. But in this scenario, we are just going to add. All right? And what we're looking for is the total time it took the 3 runners to complete the race. The 3 runners to complete the race. Go ahead and select it. Let's move forward.
We're trying to solve to see how long it took all of them together as one to run the race.
All right, my friends. All right, so the only addition to our tape diagram, it looks like, is this little piece here. You want to try and draw a little bracket. That's that little squiggly we do sometimes in class. Okay, and then make sure you put a question mark at the end of it. That's what we're looking for right here. We're looking for the total time it took all 3 runners to finish the relay race. Before we can find the team's total time, we must figure out what. What must we figure out? What don't we know exactly? If you said Marco and Lena's time, you are correct. Right now, we know Camille's time. It's listed. But Marco's time, we have to figure out what his total time is, and then we have to figure out what Lena's total time is. Once we have all 3, we can use this addition formula here, and we can find our total time. Let's move forward. First, let's solve for Marco's time. Let's create an expression to help us solve. Well, for Marco, we know if we look at his tape diagram and we look at the problem, Marco ran the same time as Camille, except he ran 1.89 seconds slower, which means it took him that much longer. So he ran 29.2, right? And he ran an additional 1.89. All right. So this right here will help us find Marco's time. Very nice job. What I want everybody to do before we move to the next slide, under your tape diagram, I want you to write this addition sentence, 29 and 2/10 plus 1 and 89 hundredths. Once you have it written, we can move on. Okay, they want us to solve using fractions, which we're going to practice. But I want to see if we can come up with the answer for Marco's time without fractions. I want to use our place value chart and see if we can work the answer first, and then we can check it using fractions afterwards. So let's take our 29.2 and our 1.89 and come right over here to our place value chart. Now we're looking for Marco's time. So we're going to take our 29 and 2/10, 29.2, and we're going to add to that 1.89. Notice what I did. Before I added anything together, I lined up my places. I put 2 into the tens place. Next to it, I put 9 into the ones place. And then my first decimal place, my tenths place, I put a 2. And then for the additional time it took Marco to run, I put a 1 into the ones place, I put 8 into the tenths place, and I put 9 into its hundredths place. Now I can add these together. Before I do so, I'm going to fill this place value, this extra hundredths place, with a 0. It's the exact same thing, but now I have a digit there that will help me add that hundredths place with the bottom value. All right, let's add them together. We'll do our answer in pink. Let's do our hundredths. 0 plus 9 is 9. 8 plus 2 is 10. We'll drop our 0 and carry 1. 9 plus 1 is 11. Carry 1. And 2 plus 1 is 3. Our answer, 3,109. That's how many seconds it took. No, that is way, way, way too long. What did I forget? If you're thinking I forgot to drop my decimal, you are correct. Make sure you bring that right down. Keep it organized. Okay. We have our 2 decimal places filled, and we have 2 whole numbers filled. Marco's time should be 31 seconds, 31 and 9 hundredths seconds. All right. All right, my friends, what I want you to do, I want you to finish your addition sentence. So make sure you have your answer, and I want you to put a box around everything. We're going to come back to this at the end. We're going to see if our answer for Marco was correct. Pause the video now if you have to write it down, and then we will continue. All right, my friends. So we're going to go through this problem again, but this time we're going to do it using fractions. So we're going to start by converting our decimal form into fraction form. Let's take our first term, 29.2. That's 29 and 2/10. 2 in the tenths place. For our back value, 1 whole and 89 hundredths. Okay? Very nice. Make sure you have that filled in, then press enter. Good work. All right, before we can add these together, I have to make sure that my fractions are like fractions. That means they need to have common denominators. I can see I have a 10 and a 100 here as denominators. That won't work. What can I change my tenths to? If you said hundredths, you were correct. If I multiply 10 times 10 to get 100, what do I have to multiply my numerator 2 by? Very nice job. Make sure you keep it the same. If you said 10, good work. 2 times 10 is 20. So we'll plug in 20 100ths here. Don't forget your whole number. Pull down that 29 in front. Okay, and now I think we're ready to add. Let's move on to our next slide. Good work. All right, now it's time to add like units. So what they did was And I love this strategy. They added together their whole numbers first. Notice they did it right here. 29 plus 1. What does that equal, friends? You got it. 30. Very nice job. And then they added together their fractions. 20 hundredths plus 89 hundredths. Notice that right here. All right, let's go ahead and add our numerators. We don't have to worry about adding those denominators. That just tells us what our unit is. 89 plus 29 plus 0 is 9. 8 plus 2 is 10. 109 hundredths. Now, some of you are thinking ahead. You're thinking, hey, Mr. Prada, that we added it correctly, but that's an improper fraction in our answer. We're going to have to change that. And you're right. We will have to change that. We're going to look at that in the very next problem. Let's press enter. Nice work. Make sure you scroll down the page. So basically what we have here is our 30, but my 109 hundredths, I'm going to pull that out here, 109 hundredths. I can pull out one whole, and I'm left with how many hundredths? So if I pull out 100 hundredths, which is one whole, how many am I left with? If you said 9 hundredths, you are correct. So we have to take our previous whole number and the whole number we just pulled out, that 1, and add them together. 30 plus 1 is 31 seconds. But we have our 9 hundredths here. Don't forget to put that into your answer, 9 hundredths. 9 hundredths. So what we did, we took our sum, 30 and 109 hundredths, and we simplified that improper fraction. We took a whole number out of it. We added it to our 30, and then we were left with our 9 hundredths. This right here, my friends, is our answer. This is how long Marco took to finish his leg of the race. Very nice job.
I know Camille's time, but we have to figure out Marco and Lena's. To find Marco's time, I added 29 and 2/10 seconds plus 1 and 89 hundredths seconds together. And then I converted it into a fraction. I need like units in order to add. 29 and 2/10 is the same as 29 and 20 hundredths. I added my whole numbers first, and then the fractions. I got 31 and 9 hundredths. Marco ran 31 and 9 hundredths seconds.
Let's pause for a second. Okay, she did a great job explaining exactly what we just did. Marco ran 31 and 9 hundredths seconds. So we have Marco's time. But remember, to do it with fractions is really good. I mean, to have those skills to convert from fractions to decimals is such a powerful tool as you guys continue to learn more and more about decimals and fractional numbers. But sometimes it's easier to just use your decimals like we did. Look how fast I do this when I stack them. 29 and 2/10. I take my ones place, I put it underneath. My 8/10, I put it there. And my 9 hundredths, and I fill the rest with zeros. Okay? 0 plus 9 is 9. 8 plus 2 is 10. Carry 1. 9, 10, 11. Carry 1. 2, 3. 31 and 9 hundredths. The exact same answer. Okay? So I love the stacking method where you stack your places so they're nice and organized. You keep your decimal points lined up, and then you just add it using the standard algorithm. Okay? It's much faster. We'll practice it both ways, but this is the method I want you to use during your exit ticket and as we move forward. All right, let's keep going because this problem's not done. We still have to figure out how long it took Lena to finish. And then we have to put them all together. We got to find out what the total amount of time is. Let's keep moving. Okay, record Camille and Marco's times in your notes. So I want you guys to make sure you have both of these times written down. Make sure you have 29 and 2/10 of a second next to Camille. Make sure you have 31 and 9/100 of a second next to Marco. And then we're going to move forward. All right, what should we do next? Well, we need to find Lena's time. Did Lena run faster or slower than Marco? I want you guys to answer this. Press enter and then check your answer. Okay, if you said that she ran 9/10 of a second slower, you are correct. Nice job. All right, let's create an expression to help us solve for Lena's time. So she ran 9/10 of a second slower than Marco. So that means she took that much longer. So if she took 9/10 of a second more, we need to add that on to the end. So let's add it right on. 31.09, that's Marco's time, okay? And then we're adding on this little piece right here that I'm pointing at, 9/10. I want you guys to write this down in your notes. This is the problem we're going to be solving. As I write it, make sure you're writing it yourself. Excellent work. Okay, again, they want us to do it using fractions. That's totally fine. We'll practice that in a second, but I want to do it using the stacking method. This time we're going to do it without the place value chart. We're going to practice it on our own. So I'm going to start with the top number, 31 and 9/100. Start by writing that nice and neat in the standard algorithm. 3, 1, decimal point, 0/10, 9/100. Okay, make sure you give yourself enough room. And once you have that written, next we're going to write 9/10 into our standard algorithm. Now think about the place there, 9/10. We don't have any 10s. We have 0 1s, so I'll put a 0 there. 0 1s. There's a decimal point. Our first decimal place, our tenths, we have 9 of them. So write that right under your other tenths place, right here. Okay? And then that's all we have. There are no hundredths, so I could just leave it blank. But what do we know we can use as a placeholder when we have no hundredths? If you're thinking 0, you're correct, okay? And now I am able to add these two values up pretty easily using our standard algorithm. Let's start with our hundredths place. Everyone, 9 plus 0 is what? 9, nice work. Let's go to our tenths. 0 plus 9 is what? 9/10, good work. All right, let's go to our ones place. 1 plus 0 is what? If you said 1, nice job. And then 3, we can just bring that down. 3 plus 0 is 3. Our answer, 3,199. Nope, we know that's way too many seconds for our answers, for our answer to be reasonable. So bring that decimal point right down. Keep it nice and organized so that your answer becomes reasonable. 31 and 99/100 of a second. I want everybody to write that right next to Lena's time. We're going to check our work using this fractional form that they want us to use. All right, so let's go ahead and do that now. We'll start with our first term. Let's change it into a fraction, 31 and 9/100. As I'm writing it, I want you to fill this in on your own computer device. And then we have 9/10. Okay, let's keep it moving. Those 9/10, we can't add those unless we change them. They need to be hundredths because we need like fractions. So those tenths must change to hundredths. What must my 9 change to? If you're thinking 90, you are correct. We multiplied the denominator and numerator by 10. And now we're able to add these together. Our whole number, 31. I don't have a whole number here. There's no whole number there. So 31 plus nothing is 31. And I have hundredths now. So 9 plus 99 is what? If you think, or 9 plus 90 is what? I gave it away. I'm sorry, my friends. 99/100. Okay, and it's not a full whole because it's 1/100 less than 100 hundredths. Okay, remember it needs to be 100 hundredths in order to change it into your 1 whole. All right, this should be our answer. Make sure you have that plugged in. And it did match, it matched what we had before, 31 and 99 hundredths.
Now we have to find Lena's. So I'm going to convert 0.9 into 90 hundredths in order to add to Marco's total. Lena's time was 31 and 99 hundredths seconds.
All right, y'all, make sure that you have Lena's written in now. And then we're going to add all 3 of these together. We're going to use our place value chart for this. Okay. And they want it in decimal form. So this is how I want you guys to do this. We're going to solve this, but I'm going to use a place value chart. So I need to find the total amount that all 3 ran. So I'm going to start with Camille's time. I'll put a C here for Camille. She ran 29 and 2/10. And then I'm going to do Marco underneath. Marco ran 31 and 9 hundredths. Put an M for Marco. And then we'll do this reddish color. Yeah, we'll do red for Lena. Lena ran 31 and 99 hundredths. She took the longest to finish, Lena. Okay, so we have 3 numbers. Notice I don't have a row here, but I just lined it up based on its place values. Tens in the tens column, ones in the ones column, tenths and hundredths. Now, our numbers are nice and organized. We can go ahead and add them together by place value using our standard algorithm. Make sure you fill that empty hundredth space with your placeholder, your 0. And let's add it together. 0 plus 9 plus 9 is 18. Good work. Let's carry our 1. 9 plus 2 plus 1 is 12. Very nice. We'll drop our 2 and carry our 1. 9 plus 1 plus 1 plus 1, that is 12. Very nice. Carry your 1. And 3 plus 3 plus 2 plus 1, that's 6, 7, 8, 9. My answer, 9,228 seconds. What do we think? Nope, it's unreasonable. That's way too much time. Don't forget to bring down your decimal point. My final answer, 92 and 28 hundredths of a second, 92.28 seconds. Very good. We'll abbreviate it. All right, that's our answer. Let's bring that right over. I'll go down. I'll write it down just to make sure I have it saved. 92 and 28 hundredths. Let's check our work. 92 and 28 hundredths. Nice work. Good job, my friends. And that took a lot of time. We're adding 3 separate values together that we had to find. But we went through how to do a tape diagram. We went through how to find individual times. And then we demonstrated how to pull them all together using addition and our standard algorithm. Excellent job.
We have to find the total by adding Camille's, Marco's, and Lena's time together. And then I converted it into a fraction. First, I added my whole numbers. Then I added my fractions, and I got 92 and 28 hundredths seconds.
All right. So let's take a look at Deja's technique, which I really love. She did a great job. But what she did was she turned all those decimals into fractions, and then she added them together, as we can see. 29.2, she made 29 and 20 hundredths. 31 and 9 hundredths she made into the fraction form, and then same with 31 and 99 hundredths. And then she added them all together, okay? We did it using our standard algorithm and kept everything in decimal form, which I personally think is just much faster, all right? That's what we're gonna be practicing, this format right here for our exit ticket. All right, Let's move forward. What was the common unit used in order to add the fractions? Well, we can see we had to change them all to hundredths. Make sure you select that and let's press enter. Nice job.
My answer is reasonable because they each ran about 30 seconds, and 30 times 3 equals 90. And my estimation is close to my original answer.
I love that Deasia used reasonableness or estimation to check her reasonableness. Basically, what she said, each of these times is around 30 seconds. So she did 30 times 3, because there's three friends here that ran. That's 3 times 3 is 9. And then I have a 0 I can put right on the end. So our answer should be about approximately 90 seconds, and we can see it's almost 90 seconds. So this answer is a reasonable answer. This answer does make sense.
The team's total time was 92 and 28 seconds.
Nice work, Deasia. Nice work, my friends out there that are working alongside us. All right, that's our lesson. It was a long problem, but that's how we want to work our word problems. We're going to practice a couple more in our Tower of Power. Let's head on over. All right, y'all, let's kick it off with lesson 14, Tower of Power. We're going to have some warm-up problems here. So let's start with our addition problem, 6/10 plus 91 hundredths, 6/10 plus 91 hundredths. Before you do anything, I want you to try this in decimal form. Let's write it, 6/10 plus 91 hundredths. Notice how I wrote it out. Now, let's go ahead and put it in our standard algorithm, 0.601 6/10. Here we have 0 ones, 9/10, and 1/100th. Notice how everything is lined up. I need a 0 as a placeholder here in my hundredths behind my 6. And now I can add them. 0 plus 1 is what? 1. 9 plus 6 is what? 15. Very good. We'll drop my 5, carry 1. 1 plus 0 plus 0, that's easy 1. And make sure you bring your decimal place down. Our answer should be 1 and 51 hundredths. I want you to write that on your scrap paper and put a box around it. We'll check it out in a second to see if it's correct. All right, let's continue with their area model. So we need 6/10 shaded in. Let's use our tenths symbol here. There's 1, 2, 3, 4, 5, 6. We've shaded 6 in. Good work. Enter. Now we need to shade 91 hundredths more, 91 hundredths. So I could count my hundredths here. 1, 2, 3. That would take forever though. Let's start by doing 10 at a time. So here's 10, 20, 30, 40, 50, 60, 70 more, 80 more, 90 more. Okay, I just added 90 more, but we need 91 more. So I need to add 1 more hundredth. Check it out. There it is. Let's see if it's correct. Nice job. And let's use our area model to answer our question, our addition problem here. How many holes do we have? Well, we have 1 area model filled in, so 1 hole. And then what do we have here? Well, it's out of hundredths. It's out of 100. So we're going to work with hundredths. And then it looks like I have 10, 20, 30, 40, 51. 51 hundredths, okay? Which looks familiar, 1 and 51 hundredths. I think, yep, that's what we had written down before. Very nice work, my friends. Nice job. And we just wrote it out. I want everybody to write this in decimal form and then press enter. If you wrote 1 and 51 hundredths, you are correct. Good work. All right, let's move on. Okay, we're going to keep on climbing again. They want us to solve using fractions. We're going to do it. We'll do it, Zearn. I think it's a great idea. But before we do, we're going to use our standard algorithm and stack these two values. Let's start with our first numbers here. 6 and 9 tenths. We have 6 ones and 9 tenths, 6.9. And for our second value, we'll do that in green. 7 and 8 tenths. That's 7 ones, so we put it under our 6. And 8 tenths, put that in the tenths column or first decimal place, and add them together. Let's do it. Let's do it in pink. 9 plus 8 equals what? If you said 17, correct. Drop our 7, carry our 1. 7 plus 6 plus 1 equals what? If you said 14, you're correct. Nowhere to carry that 1 here. I'm out of digits. So I'm going to bring that 1 down. And my answer is 147. Nope. Can't forget about my decimal. Bring that decimal point down. Our answer should be 14 and 7 tenths. I want everybody to write that down on a separate piece of paper, that piece of scrap paper you're using. Make sure you put a box around it just so we can check it later. All right, let's see if we can find it using our fraction form. So we have 6 and 9 tenths. Go ahead and plug that in, my friends. And what are we adding that to? If you said 7 and 8 tenths, you are correct. Great job. All right, I want you to add these together. Pause the video now. You can check your work when you are done. Okay, it's time to check. Let's do it. Start by adding your whole numbers together. 6 plus 7 equals what? If you said 13, you are correct. And then let's go ahead and add our fractions together. 9 tenths plus 8 tenths. How many tenths will that give us? Well, 9 plus 8 is 17, so that's 17 tenths. But those brains should be buzzing right now. What looks a little bit off about our answer here? What's different about our sum that we need to think about moving into the next slide? Go ahead and press enter and really just think about what we're going to have to do next. Okay, notice what they did. Zearn recognized that this right here is correct, but we have an improper fraction. So we can't leave an answer with an improper fraction. We're going to have to take as many wholes out of it as we can. So we took 10 tenths out, which we know equals 1 whole. Okay, so we took 10 tenths out. And then what are we left with? Well, if we take 10 tenths out of this 17, we take that 1 out pretty much. What am I left with? Correct, 7 tenths. Very nice. And for our final answer, we have a new whole number that we need to add in. So we have 13 plus 1. That gives us 14. Nice work. And then we have 7 tenths as our fraction. Good job, my friends. Let's go ahead and press enter. Nice work. Okay, and they want us to list our number they want us to write our answer in decimal form. So we have 14 and 7 tenths. Let's go ahead and write that. 14 and 7 tenths, 14.7. It matches what we have written down. Nice work. Snaps for everybody. Let's keep it moving. Great job. Let's keep climbing. All right, my friends, here we have a word problem. It's up here in our purple tab. Let's read it. Juanita drank 2 2/10 liters of water during soccer practice. Carl drank 1 5/10 liters of water. Together, how much water did they drink? So start to think about the problem. Let's visualize it. I'm going to close my eyes. They're at practice playing soccer. It's hot out today. They're probably sweating, right? So they need to drink water. Juanita drinks some. Carl drinks some. Do they drink the same amount? Do they drink a different amount? What do we think? Well, we can see in our problem, I'm going to underline it here, that Juanita drinks 2.2 liters. And after I underline it, I'm actually going to mark that on my tape diagram. And I want everybody to draw this tape diagram. So what you're going to do, you're going to draw one box like this, and you're going to attach it to another, just like this. You want to draw two rectangles back to back. You can put a J in one, and you can put a C in the other. J for Juanita, C for Carl. And then underneath, you can write 2.2 for Juanita. And then how much did Carl drink? Do we know what he drank, or do we not know? If we didn't know, we put this, right? But I think we do know what he drank. Carl drank 1.5 liters, 1 5/10. So let's plug that right there. I'm going to write it down, 1 5/10. Okay. And last but not least, we have one more piece that we have to move around. We're looking for together, how much water did they drink? Well, together is the same as sticking two things right next to each other. If I have two pens, okay, and I want them together, I have to add them up. I have to put them together. 1 plus 1 is how many pens? 2 pens. Very good. So we're going to end up adding these two values to find the total. Let's plug that question mark right there, and we're going to move forward. Good work. All right, Juanita and Carl drank a total of blank liters of water at soccer practice. I want you guys to use the standard algorithm and tell me how much did Juanita and Carl drink together. Plug your answer and press enter and see if you're correct, and come back to check your work against mine. I'll see you in a second. All right, y'all, you're back. I hope those standard algorithms went well. We have 2 2/10 plus 1 5/10. My ones are stacked. My tenths are stacked. My decimals are stacked. We are ready to add. Let's use our standard algorithm. We'll start with our tenths place. 2 plus 5 is 7. Good work. 2 plus 1 is 3. I already put my decimal place right down there between my ones and my tenths. And our answer is 3 7/10 liters. Plug it in. Let's see if we're correct. Hey, nice job. Let's keep going. All right, my friends. So we have to fill in this tape diagram. Before we do so, let's read our problem. It's up here written in our purple bar. A baker used 4 33/100 kilograms of flour on Monday. He used 1 5/10 more kilograms of flour on Tuesday than Monday. He used more on Tuesday. How many total, alarm should be ringing in your head, total kilograms of flour did he use on Monday and Tuesday? Okay, so we want to find out how much he used Monday and Tuesday together. To do so, we're going to start with this tape diagram. You guys don't have to write this one down. This is a perfect one here on our Zearn example. On Monday, how much flour did he use? Let's underline that piece in the problem. Looks like he used 4 33/100 kilograms of flour on Monday. Let's plug that in. So we want to grab the correct number here, 4 33/100. Make sure you drag that to Monday. And then for Tuesday, we have to fill that in. Well, it looks like he used a little more than Monday. How much more? So he used 1 5/10 more kilograms on Tuesday. Okay. So that's how much more he used. All right. So that means he had to have used 4.33, 4 33/100, and then he used a little bit more. Okay. Nice job. The baker used blank kilograms of flour on Monday and Tuesday. So we need to find out how much he used total. I'm just going to draw this. I'm going to put a little question mark here because we're looking for these two added together. Okay. So let's go ahead and do it. There's a couple ways you can do it. You can do it piece by piece. You could add all three terms together. I'm going to start by adding 4 33/100 twice. So I'm going to start by adding these two together. Let's do it on the side here. 4 33/100 plus 4 33/100. My ones are lined up, my tenths are lined up, and my hundredths are lined up. We're ready to add. 3 plus 3 is 6. 3 plus 3 is 6 in my tenths place. 4 plus 4 is 8. We got to make sure that we drop down our decimal so that we have 2 decimal places just like in our problem here. And our answer is 8 and 66 hundredths. But that's just for these two quantities. We still have to add 1.5. So let's take 8 and 66 hundredths, and we're going to add 1 whole, 5 tenths. Notice, I had to leave this place open right here. When I created my standard algorithm, I left that open because in the additional amount of flour, right, there aren't any hundredths. I have to fill that space with a placeholder, with a 0. And now I'm able to add these two together. Let's do it. Let's do it in orange. Okay. So we'll start with our smallest place, our hundredths place, 6 plus 0. That's pretty easy. 6. Nice job. 6 plus 5. How many tenths is that? 11 tenths. Good. Let's carry 1. One of those will turn into, or 10 of those will turn into a 1. So now we have 1 plus 8 plus 1. That equals 10. Drop my 0. Nowhere to carry the 1, so that comes down 2. And where do I put my decimal? If you said between our 0 and our 1, you are correct. This is our final answer. Our baker friend here used 10 and 16 hundredths kilograms of flour. 10.16. Let's see if we're correct. Excellent job. Give yourself some snaps and let's move forward. Awesome work, my friends. Good job. Okay, so we're done on Zearn. I hope you guys feel comfortable, more comfortable adding together your decimals and working some of the values from word problems into your standard algorithm for addition. What I want to do is I want to go over a couple problems on your exit ticket. Today you have 6 problems. Head on over to Edge Elastic. You can pause the video now. I'll see y'all in a second. All right, y'all. We are on our exit ticket. You guys will be taking this exit ticket on Monday, May 4th. This is attached, we'll say, to Module 6, Lesson 14, what you guys just finished over on Zearn. Again, make sure you're watching all the way through this video. I gave a lot of really good tips, tricks, hints, and strategies for using your standard algorithm. So you're going to want to make sure you're watching this video. These are mandatory, these videos. All right, but also complete that Zearn lesson so you get your practice in. Now let's look at our first problem. I want everybody to read along as I read aloud. The snowfall in year 1 was 2 3/100 meters. The snowfall in year 2 was 1 6/10 meters. How many total meters of snow fell in year 1 and 2? All right. So I want to start by circling my numbers. 2 3/100, 1 6/10. Okay, year 1 and year 2. Right. Year 1. Let's do a tape diagram as well. Year 1 and year 2. Okay. Next, I'm going to underline my main question. How many total meters of snow fell in years 1 and 2? So I want to find the total amount of snow that fell in years 1 and 2. Well, how much snow fell in year 1? We can see 2.03 meters fell in year 1. How much snow fell in year 2? We can see 1 6/10 meters fell in year 2. Now, to answer our question, we need to think about what operation, we're going to look right here at this hint, What operation helps you find the total amount of something? Well, just like in our Zearn lesson, we're going to rely on addition to help us solve these two unique values right here. All right. And you could use fractions if you want to. We could convert them to fractions. If you want to do that, if you feel comfortable, that's okay. But do it after you practice your standard algorithm with decimals. That's what I want you to practice. So for this first one, we're going to do it in our place value chart. We have 2 3/100ths. And we're adding it to year 2, which is 1 6/10. We want to make sure we add these together. So let's come over to our place value chart. Let's wipe this clean. Okay. Year 1, I'm going to put Y1 is 2 3/100ths. And underneath of it, remember, you guys are doing this on your own scrap paper. Yours is probably going to look like this. All right. It'll be sort of open. It won't be in a place value chart unless you want to create your own or you want to download one like this. That's totally fine too. Let's plug year 2 in. Year 2 is 1 6/10. That's 1 whole and 6/10. No hundredths. So I need to put a 0 there. No hundredths. There's no second decimal place. I'm going to write it over here too. 1 6/10. Remember that 0 in our hundredths. And now we're ready to add these together. We'll do it in blue. Okay. Start with your smallest place here. So our 3 plus 0/100ths, that's 3/100ths. 0 plus 6, that's 6/100ths. All right, drop your decimal point. Make sure it's lined up. And then our ones, 2 plus 1, that's 3 ones. Our answer should be 3.63. And I think we were in meters. Okay, we'll come back here. Always in word problems, especially make sure you're putting your units. 3 63/100ths meters. Let's add it here just so you guys have it. 3/100ths, 6/10. Nothing to carry, but I want to drop that decimal point, and then our ones place, 2 plus 1 is 3. 3.63. So for your answer, what you're going to have to do, you need to explain this to me. How did you find your answer? How did you use your standard algorithm? Okay, 3.63 meters. I want you to start by telling me your answer. Make sure you include it and then give me your strategy. How did you line your digits up, your places up? Did you use the standard algorithm? Did you maybe draw a tape diagram like I drew? Any technique that you guys used, I want to see it. And I especially want to make sure that you're including that answer. That's the main piece of this. All right, let's go over one more. Let's look at question number 2. A deli sliced 22 6/10 kilograms of roast beef 1 week and 13 53/100ths kilograms the next. How many total kilograms of roast beef did the deli slice in 2 weeks? I love deli sandwiches. I think my favorite sandwich actually is maybe, let's see. I love a roast beef sandwich. I also love an Italian hoagie. In fact, I guess anything from the deli I like. So let's add these together. Well, let's break it down first. Let's start by circling our values, 22 6/10, 13 54/100ths. Next, I want to underline our question. How many total kilograms of roast beef did the deli slice in 2 weeks? Now, there's a word here that tells us what operation we should probably use to find the total kilograms of roast beef the deli sliced in 2 weeks. All right. And it's this word here, total. We've been talking about it all day. Total means what? If you're saying addition, you are correct. Nice job. I'm going to do it the same way. I'm going to draw my tape just like this. Week 1, W1, and week 2, I'd like everybody to practice this on their scrap paper, so make sure you're writing this as I write it. All right, so we want to find the total. So I'll put this cool little squiggly here that stretches the whole length of the tape diagram and a question mark at the top. We're looking for both of those together. Let's write the quantities underneath. Week 1, the deli slice, 22.6 kilograms. And in week 2, 13 and 54 hundredths kilograms, okay? If I want to find the total amounts, I need to add these together. We're going to use our standard algorithm. So start by writing 22 and 6 tenths. That's a tens, a ones, and a tenths place. Underneath, let's write our second value here, 13 and 54 hundredths. Notice everything's nicely stacked. My tens, my ones, my decimals, my tenths. I don't have a hundredths place up here, but we know what we're going to use for our placeholder. Plug your 0 in and go ahead and add. Let's add these together. 0 plus 4 is what? If you said 4, you were correct. 6 plus 5 is 11. Drop 1. Carry 1 to your ones place. 3 plus 2 plus 1, that's 6. 2 plus 1, that's 3. Our answer, 3,614. That's not right. I forgot my decimal. Let's drop the decimal point down. My final answer, 36 and 14 kilograms. Make sure you put your kg at the end. This is your answer. I want to see at least 2 sentences describing exactly what we did to find that answer. How did you use the standard algorithm? What did you need to add together? So I gave you the answer for the first 2. We worked together, okay? Make sure you're writing this down and make sure you're including these when you answer your questions. The rest are on you. There are 4 more problems. These techniques will work for the majority of them. Try your best. If you need help, reach out. I'll be here. Proud of y'all. We're in May. The year's zooming by. I miss everybody, and I'll talk to you soon.